Alright, so let's do number 5. First we want to split this paper in half. So I'm going to measure, it's 11 inches long, so I'm going 5.5 to the nearest line to 5.5. And I'm going to put a line down the middle. Okay. Number 5. Solve the following system of equations. Okay, and I have y equals x squared minus x minus 12, and I have y equals x plus 3. Okay, now we're going to start with the quadratic equation, and this is a parabola, right? Because it's only got one term squared, one variable squared, and then this is obviously the line because nothing is squared. Alright? So again, let's look at the general form for the equation for a parabola. Okay, that's the general form where a, b, and c are numbers. And let's put our equation underneath it. Now we don't have to actually rearrange our equation because it's already been arranged perfectly for us. The squared term goes first, then the x term, and then the number that goes by itself. Alright, so now let's start picking out our a, b, and c. Now, a is what's in front of the x squared, which in this case is just a 1, right? Even though it's not there, we know that there really is a 1 in front of that x squared. Now in front of this x, there's also a 1, but you have to be careful because there's a minus sign in front of it, so this is a negative 1. So b is negative 1, and then our c is a negative 12. So let's find the axis of symmetry. By using the formula x equals negative b over 2a, alright, which is negative 1, be careful there, over 2 times 1, and that would just be 1 over 2. So the axis of symmetry is 1/2, alright, it's the line x equals 1/2. Okay, so let's create our table now. We know we're going to have x and y values. Okay. And 1, 2, 3, the fourth one down is going to be that 1/2, right? That's our axis of symmetry. So now let's create our table here. Just draw it in. Okay. And even though the axis of symmetry was a 1/2, we still are going to go up to the next whole number and down to the next whole number when we do our table here. Okay? So we're not going to go, in other words, to 1.5 right here. We're just going to go to 1, and then 2, and then 3. And then we'll go to 0, negative 1, negative 2. Now let's use our calculator to fill in the rest of the values in that table. Okay, so what we have is, we have x squared minus x minus 12. And I'm going to hit second graph to go to my table. Alright? Now we can't see the 1/2 here, but we actually can change our table to get that 1/2 back. And what you do is, if you see all the x's are going by 1, we can change that. We can make the x's go by whatever we want. So I'm going to go into table settings. That's this table set right here. So I'm going to hit second window. And it says the table starts at -2, which is good for us because our values start at -2. Now that little triangle TBL, that's the change in the table. That means how much do you want the table to increase by. We want to change that to 0.5. Alright, and that's it. Now we just hit second table. And now look, it's going by 0.5 each one. So at -2 we're -6. At -1 we're -10. At 0 we're -12. At 1/2 we're -12.25. So I got to squeeze that in here. I'm actually going to just extend my table a little bit here. -12.25. Okay. At 1 we're at -12 again, so now we're going back down the other way. At 2 we're at -10, and then at 3 we should be at -6. Okay. Now let's do our graph. Okay. So first I got to set it up. I want to go halfway between the middle and the end, so it's about 5.5. Right? So I want to go 2 3/4. Okay. There's my y-axis. Now I want to do the same thing on this side, but now this is going to be 8.5, so I want to go 4 1/4. So the closest line to 4 1/4 is, really it's either one, but I'll choose that one because it was right in between two of them. Okay. Let's put our X. Let's also label our quadrants before I forget. Oops. Okay. So, and we also have to show whoever is looking at our paper that we're going by 1 in all 4 directions. Okay? Now, let's plot our graph. We have -2, -6, -1, -2, -1, -2, -3, -4, -5, -6. And we have -1, -10. -1, this is -6, -7, -8, -9, -10. 0, -12. So this was -10, so 2 more down. 1/2, -12.25. That's -12 1/4. So we go to 1/2. Now this is the lowest point of our parabola. And we go to -12, and then it's 1/4 of the way. So I'd say right about there is good. Whoop, let me move that up for you. Okay? Right in the middle of halfway and at the beginning. So 1/4 of the way. And now I do 1 -12, and I do 2 -10, and I do 3 -6. Okay? So, let's draw this in. Okay, and let's put the equation on the line. Y equals x squared minus x minus 12. And we didn't draw the axis of symmetry yet, right? Which is x equals a half. So let's put that in. It goes through 1/2 on the x-axis, so it's halfway between 0 and 1. And it's a dotted line. Notice how it goes right through the turning point of the parabola. Okay, and we need to identify the axis of symmetry. So, axis of symmetry, x equals 1/2. And now all we have to do is plot our line. So let's go back and look at our line. Okay, as you can see, it's already in y equals mx plus b form. So let's just pick out our m, which is 1, and our b, which is 3. Okay, which normally we want to rewrite that as a fraction, 3 over 1, right? Oh no, we don't have to do that. That would be our slope that we write as a fraction, but we don't even have to. Hopefully at this point you know how to graph a line. So we start at 3. 1, 2, 3. And our slope is positive 1. So that means we go up 1 and to the right 1. Up 1 to the right 1. Up to the right. 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 We also go down to the left. Down to the left. Down to the left. Down to the left. So let's draw in our line. Y equals x plus 3. Now, you can't really see where these two things cross. I mean, it looks like this one crosses right at this point, but we really don't know that for sure because the only points we actually plotted on this parabola were down here. So those are the only points we know for sure. Then we just kind of drew this thing going in the direction that it heads, but we don't know exactly. I mean, if we plotted more points, we could probably figure that out. But instead, we're just going to look at our graph on a calculator. Okay. Put the line in. We have y equals x plus 3. And now let's go to zoom and z-square. Okay. So it looks like, according to the graph, it looks like the parabola really crosses right here. I mean, we're just estimating how it goes up. Okay, but it looks like it really goes up a little bit, and it looks like it's going to cross right here. And it looks like what we did over here is good. It looks like it's going to cross there, but we have to check. So let's do second trace to go to calculate, intersect. We're going to put it near the first intersection on the left. Where's my blinking cursor? Oh, it's probably at the bottom of my parabola and I can't even see it. Yep, here it comes. I'm moving it to the left. Now it's close enough to that intersection. I push enter. That point is close, so I push enter. And now it says, do you want me to guess? And I say yes, enter. At -3, 0. So it actually crosses right here. So what I want to do is just erase this part of my parabola, and I'll just draw it a little better. Okay, so I know it crosses through this point, so I'm going to draw it crossing through that point. And now it doesn't really matter from here, it goes up. Okay. Okay, so most of the time the line will cross like an obvious point, but not always. So we have to know how to use the graphing calculator for this. Now hopefully it crosses at that point, but we have to check. Second trace to go to calculate, intersect. Now we got to move this blinking cursor all the way over to that little, right there is close enough. Okay, I push enter, I push enter again, and I push enter again. At 5, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it does cross right there. I got lucky when I went up with this line. I went up at a perfect angle. So let's circle our points of intersection. Okay. Now, let's identify those points. So I'm going to put it on the bottom left over here this time. I'm going to say -3, 0, and I'm going to say on x-axis, right? Because it's not in a quadrant, it's on an axis. And then I'm going to say that was at 5, 8. And I'm going to say in quad for quadrant, and that's quadrant 1. Alright, now we're almost done. The only thing we have left to do now is to check. Okay? So I'm going to do that over here. So first I'm going to check the point -3, 0. And I'm going to check it in the quadratic equation first. Y equals x squared minus x minus 12. So y is 0 and x is -3. So just put everything, be careful here, see it's minus x and x is -3, so it's minus, and I'm putting a -3 in parentheses, minus 12. So we have 0 equals, when you have a -3 inside parentheses and you square it, you get a positive 9, because that's -3 times -3, that's positive 9, minus -3, that's plus 3, and then minus 12. So that means 0 equals 9 plus 3 is 12, minus 12 is 0. So that checks. Okay, now let's check the same point in the linear equation. Y equals x plus 3, 0 equals -3 plus 3, 0 equals 0. It checks. Now let's check our other point, 5, 8. Y equals x squared minus x minus 12. 8 equals 5 squared minus 5 minus 12. Okay. 8 equals 25 minus 5 minus 12. 8 equals 8. It checks. And let's check it now again in the other equation. Y equals x plus 3. 8 equals 5 plus 3. 8 equals 8. And it checks. Alright, let's just clean up our check. Okay. Oh, got one line on the bottom there. Clean up our check. Alright, so that is problem 5. Alright, now let me just sharpen this. Turn this over. And we're going to do problem 6. First I'm going to draw my line down the middle here. Okay, problem 6. Solve the following system of equations. Graphically. Alright, and the first equation is y equals x squared minus 3x minus 4, and the second equation is y equals x minus 10. Okay, this is obviously the parabola. It's only got one term squared, and this then is the line. So start with your general form for the equation of a parabola, or then put your equation underneath it. And I don't have to rearrange anything because it's all written down properly for me. It's in order. So now just pick out your A. A is 1 here. Your B. B is negative 3. And your C is negative 4. So let's find our axis. Symmetry. X equals negative B over 2A. That equals negative 3. You see how many times they do this with that double negative? So you better know not to make that mistake. Over 2 times 1. That's going to be 3 halves. Okay, they're starting to give us some fractions here for our axis of symmetry and stuff, but we're not going to worry about that. X equals 3 halves. Alright. By the way, that's 1.5. So if you want to also put that next to it, you can, but I'm not going to. Alright, so xy, 1, 2, 3. In the middle we have 3 halves. Alright, let's put in our other values before we actually draw in our table here. So I'm clearing my other equations and I'm putting in just the parabola for now. X squared minus 3x minus 4. And I want to go to second table. Now it's going by a half right now, but I really want to just go by ones. Actually, no, I do need to go by a half because I have 3 halves. So let's find 1.5. And that's negative 6.25. Okay. Why don't we change this to a decimal? Because the rest of the table is in decimals, so we might as well do the same thing. So I'll move my x over. We had it at 3 halves is equal to 1.5. Alright, I'm actually going to line that up with this side. So my x is going to be right in the middle of that column, and my y will be right in the middle of that one. Alright, now let's see. We're going to go up by 1, up to 2, I mean actually. And at 2, we are negative 6. Then we're going to go to 3. We're negative 4. And to 4, we're at 0. And we're going the other way. To 1, we're at negative 6, and it should go backwards, right? At 0, we're at negative 4. And at negative 1, we're at 0. Okay? So that worked out just fine. Our table is just a little wider this time to fit those decimals. Okay. So, let's draw our graph. Which is at 2 3/4. So this is the y-axis here. Find our x. It's at 4 1/4, which is right about this line. Well, so far we've lucked out, and a half of a page has been big enough. If it turns out that your graph is too small during the Regents, then you have to do it over and do it on a full-size sheet. So let's label our quadrants. And let's let everybody know what we're going by in each direction. To the positive x we're going by 1s, to the positive y by 1, to the negative x by -1, and to the negative y by -1. Alright? Let's graph. -1, 0. I'm going to start at the top. -1, whoop, that's 0, 0. -1, 0 is right there. 0, -4. 1, -6. 1 and a half, -6.25. So that's 6 1/4. A little bit below the line, just like that. 2, -6, 3, -4, and 4, 0. Okay. See, now I'm just going to do my best to judge how I think this is going to go up. It's going to just go up at a slight should go up just like that, kind of. And this side, same deal. Okay, let's put the equation. Y equals x squared minus 3x minus 4. Let's put our axis of symmetry at 1.5. Okay, so I'm going to actually write it like this time along it. Axis of symmetry, x equals 1.5. Okay, now I just have to draw my line. And lucky for us again, the line is already in y equals mx plus b form, so m is 1 and b is negative 10. So I start at negative 10 on the y-axis, and I go up 1 over 1. So according to this, it does not even look like, and I go down 1 to the left 1 also, it does not even look like our line is going to touch the parabola at all, and that's okay. That can happen. Let's put y equals x minus 10. Now, before we write down no solution, let's check it on our calculator to make sure we didn't make a mistake. Whoops. X squared minus 3x minus 4, and then it's x minus 10. Zoom z square. Yep, and we're right. The line does not hit the parabola, so you write down no solution, and that's it. You don't have to do any check because there's nothing to check. Okay, so let's put that aside. Sharpen the pencil. All right. Next sheet. Okay. We want to go halfway to 11. That's 5.5. So I'm gonna make my line down the middle here. All right. And we're on number 7. Solve the following system of equations graphically. And I have y equals x squared minus 4x plus 6 and y equals x plus 2. Well, they made this one easy for us again. Everything is in order. This is the parabola. This is the line. Y equals ax squared plus bx plus c. Y equals x squared minus 4x plus 6. Our a is 1. Our b is negative 4. And our c is 6. So our axis of symmetry, x equals negative b over 2a, which equals negative 4 over 2 times 1, which is 4 over 2, which is 2. So our axis of symmetry is x equals 2. So we should have nice values here. Our middle value is that axis of symmetry point. And let's look at the rest of our values using our calculator. X squared minus 4x plus 6. The table's going by a half, so let's change that. Second window to go to table set. Let's change our delta table to 1. Now second graph, go back to the table. And there you have it. At 2, our y is 2. And then we have 3, 4, and 5. And we have 1, 0, and negative 1. At negative 1, we're at 11. At 0, we're at 6. At 1, we're at 3, 2, 2. And now we should go back the same way. 3, 3, 4, 6, 5, 11. Okay. And we can also look at our line and see that our slope is 1 and our y-intercept is 2. So let's graph both. Let's go 2 3/4, which is halfway to 5 1/2. Oops. Then we'll go to 4 1/4, which is halfway to 8 1/2. Over there. Let's label our quadrants. Upper right's quadrant 1, upper left is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. And we got to show everybody what we're going by on our axes. We're going 1, 1, -1, -1. Alright? Let's graph. -1, 11. 0, 6. 1, 3. 2, 2. 3, 3. 4, 6. And 5, 11. All right. Okay. And this is y equals x squared minus 4x plus 6. And let's graph our line. We start at 2, which is our y-intercept, and our slope is 1. So it's up 1 over 1, 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 all the way. And we can also go down 1, all the way, down 1 over 1. So that's enough points. We really only need 2, but it's nice to be able to line your ruler up with more points. Circle the solutions. Let's draw in our axis of symmetry, which is at x equals 2. Goes right through the lowest point or the highest point of the parabola. In this case, it's the lowest point. The turning point. I'm going to label it down here so it's out of the way of everything. Axis of symmetry is x equals 2. Now let's just identify our points. 1, 3, which is in quadrant 1. And there's also 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 4, 6, which is in quadrant 1 also. Let's check using our graphing calculator. X plus 2. First let's go to the table and let's look at 1, 3. Notice they have the same 3 for the y's. When x is 1, they're both 3. And when x is 4, they're both 6. Also go to zoom z-square, and let's make sure the graph looks like ours. Okay, and it does. So we know we did it right. Let's show our check. First we'll check 1, 3, which is y equals x squared minus 4x plus 6. 3 equals 1 squared minus 4 times 1 plus 6. 3 equals 1 minus 4 is negative 3 plus 6 is 3, so it checks. We also have to check that point in the line. Y equals x plus 2. 3 equals 1 plus 2. 3 equals 3. It checks. Next point, 4, 6. Y equals x squared minus 4x plus 6. 6 equals 4 squared minus 4 times 4 plus 6. 6 equals 4 squared is 16, minus 16 is 0, plus 6 is 6. So 6 equals 6. And let's check it in the line. 6 equals 4 plus 2. 6 equals 6. So we're all good. Let's just clean up our check. Okay. So that was 7. Alright, we've done all our work, showed everything we need to. Now let's turn this over and do number 8. Solve the following system of equations. Okay. Let's see what we got. We got y equals 1/4 x minus 3. And we have y equals x squared plus 8x plus 12. Okay? Well, this time the line is on top, it doesn't matter, and the parabola is on bottom. Right? So let's start with our parabola first, like usual. Y equals ax squared plus bx plus c. Let's put our parabola underneath it. X squared plus 8x plus 12. Let's identify our a, which is 1, our b, which is 8, and our c, which is 12. Now let's figure out our axis. Symmetry. X equals negative b over 2a equals negative 8 over 2 times 1. Right? So that's negative 8 over 2, so negative 4. So our axis of symmetry is -4. X equals -4. That's the equation for our axis of symmetry. It's also the middle value of our table. So let's do that now. And let's pick three numbers increasing, so -3, -2, -1, and 3 going down, -5, -6, -7. Let's see what we get on the calculator. X squared plus 8x plus 12. Second table. Let's go up to -7. We got 5. -6 is 0. -5 is -3. -4 is -4. -3, -3. -2, 0. -1, 5. Okay. Now, let's do our line. I'm going to bring it down here, okay, so that it's not negative, it's just 1/4, so that we can identify the slope and the y-intercept. Oops. 1/4 x minus 3. So our slope is 1/4, and our y-intercept is -3. Okay. Let's go back over here and start graphing things. 2 3/4. Okay, let's label our quadrants. Alright, and let's show everybody, let me sharpen this. Show everybody that we're going by ones in each direction. Now, let's put in our axis of symmetry first. Goes right down through -4 on the x-axis. Okay. Let's label that axis of symmetry. And that would be x equals negative, whoops, x equals -4. So, let's plot our parabola. -7, 5. So this is -4, 5, 6, 7, 1, 2, 3, 4, 5. -6, 0. -5, -3. -4, -4. Here's our turning point, right? Now we're going to head back up. -3, -3. 2, 0. and negative 1, 5. Alright, so here's our parabola. Let's put our equation on it. Y equals x squared plus 8x plus 12. Alright, now let's graph our line. We go to negative 3 on the y-axis, that's where we start. It's our y-intercept. And we go up 1 and to the right 4. Up 1, 1, 2, 3, 4. Let's do it one more time. Up 1, 1, 2, 3, 4. And let's also do the opposite from the y-intercept. Let's go down 1 and to the left 4. Down 1 to the left, 1, 2, 3, 4. Right on that vertex point. Down 1 to the left, 1, 2, 3, 4. So it looks like we're only going to have one point of intersection. This is y equals 1/4 x minus 3. So we have one point of intersection, which is the turning point. So let's put down our answer. It's negative 4, negative 4 in quadrant 3. Alright, and I circled my point. Now I just have to check that one point. So I only have to do 2 checks instead of 4. I'm checking the point negative 4 comma negative 4. First in y equals x squared plus 8x plus 12. Negative 4 equals negative 4 squared plus 8 times negative 4 plus 12. Negative 4 equals 16 minus 32 plus 12. Negative 4 equals 16 minus 32 is a negative 16, and negative 16 plus 12 is negative 4 or minus 4, so that checks. And let's just check it in the linear equation. We have y equals 1/4 x minus 3. So y equals 1/4 times negative 4. Whoops, that should be negative. The y turns into a negative 4. So negative 4 equals 1/4 times negative 4 minus 3. Negative 4 equals 1/4 times negative 4 is negative 1. Because the negative 4 goes on top. And negative 4 divided by 4 is negative 1 minus 3. So negative 4 equals negative 4. And it checks. So let's just clean this table up. Alright, so that is the end of number 8. Okay, now let's go on to number 9. Let's cut this paper in half. We go 5.5 is closest to, looks like this one. So I'm going to draw a line down the middle. Number 9. Solve the following System of equations. Oh, graphically. It will say that because you guys actually, believe it or not, learned how to solve this algebraically last year, but they're going to want you to do it graphically this year. Before we go on, let's look back at 8. Let's check it on our calculator. I already have the quadratic in there. Let's put in the linear equation. Now watch how I do this. I'm putting in 1/4. You have to put the 1/4 in parentheses. If you don't, you'll get the wrong answer. 1/4 x minus 3. I'm going to hit zoom, z square. Let's look at our graph first. Yep, it looks just like what we have. It looks like it crosses it at one point. Let's check the intersection. Second trace to go to calculate, intersect. We only need to put the cursor near... Where is the blinking cursor? I don't even see it. Hold on a second. There it is. It was way up there. So I'm bringing it down. I'm going to hit enter, enter, enter. Ooh, it gave me a bad point. Let's try that again. Let's check our graph. X squared plus 8x plus 12. 1/4 x minus 3. Okay, second calculate. Intersect. That's right on there. I don't know why. Let's try that point. Huh. That's really, really odd. Don't know why it's doing that. It should be giving us -4, -4. Let's go to the table and take a look. If we go down to -4, yeah, the table has it. See, -4, -4. I don't know what's going on with the graph. That this normally does not happen. Okay, it's usually always right on. So that just shows you can't just go by the graph on the calculator either. You have to also check the table. All right. Okay. Glad we did that. So, number 9. First we have y equals x squared minus 6x plus 10. And then we have y plus x equals 4. So this is obviously our parabola. It's only got one variable squared, and this is our line. So we have y equals ax squared plus bx plus c. Underneath that we write down our quadratic. X squared minus 6x plus 10. We identify our a is 1, our b is -6, and our c is 10. Then we solve for the axis of symmetry. X equals -b over 2a, which equals -6 over 2 times 1, which is 6 over 2, which is 3. So our axis of symmetry is x equals 3. That's our middle table value. Let's find our other values. We got to clear out the old stuff and put in the new quadratic, x squared minus 6x plus 10. Hit second table. Wow, we want to go down to 3. And we want to go 3 below, so 2, 1, 0, and 4, 5, 6, and 3 above. So let's go till it's 0 at the top. Okay, there it is. So at 0 we're at 10. At 1 we're at 5, 2, 2, 3, 1, 4, 2, 5, 5, 6, 10. Okay? Okay, so let's also rearrange our line equation. Okay, what we have is y plus x equals 4, but we want it in y equals mx plus b form. So we subtract x from both sides, which gives us y equals negative x plus 4. Notice how I put the negative x part first. So our m is negative 1 and our b is 4. So I'm going to graph this 2 and 3, that goes to there. Let me draw my graph first. Halfway to 8.5 is 4 1/4. That's right there. Let's label our quadrants. This is quadrant 1. This is quadrant 2. Quadrant 3. And quadrant 4. Let's not get sloppy here. Alright. Let's show everybody what we're going by on our axes. We're going by 1s. Okay? So, the parabola. Let's do our line of symmetry first. It's x equals 3. Our axis of symmetry, line of symmetry. It is a line of symmetry, but it's called the axis of symmetry when you're using it in this type of a problem. But it is a line of symmetry of the parabola. It's got a special name when you're working with quadratics and parabolas. It's called the axis of symmetry. So let's label it right on there. Axis of symmetry is x equals 3. Now the parabola 0, 10 1, 5 2, 2 3, 1. There's our turning point. 4, 2 goes back up, same distance from the axis of symmetry. 5, 5 6, 10. Let's write the equation. Y equals x squared minus 6x plus 10. And now let's graph our line. We start at 4 and we go down 1 and to the right 1, because this is really negative 1 over positive 1. So we go down 1 to the right 1, down 1 to the right 1, starting at 1, 2, 3, 4. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. We could also do the opposite by going up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. That's enough points. Looks like we're going to have 2 points here. Okay, so let's put our equation. Y equals let's put our original equation, which is y plus x equals 4. Let's circle our two intersection points. So let's now write down our solutions. The first one is 2, 2, which is in quadrant 1. Then we have 1, 2, 3, 1, which is also in quadrant 1. Let's take a look on our calculator. We already have the quadratic, so now let's put in the linear equation. Notice you can't put in the y plus x equals 4. You have to put in the y equals mx plus b version, which is y equals negative x plus 4. Now let's hit graph to see if it looks the same, which it does. Now let's hit our table. Let's just look at our values. When x is 2, both y's should be 2, which they are. And when x is 3, both y's should be 1, which they are. Now we just want to check our graph again. Let's check our intersection points. Let's see if it gives us the right answer this time. I tried to go near the first left point, 2, 2, that's our first one. Second trace, go to intersect again. I'm going to go over a little bit more towards the very bottom. Enter, enter, enter. 3, 1. Okay, so it worked that time. No problems. Alright, now we just have to do the check. Check our first point, which is 2, 2 in our quadratic. Y equals x squared minus 6x plus 10. 2 equals 2 squared minus 6 times 2 plus 10. 2 equals 4 minus 12 plus 10. 2 equals 4 minus 12 is negative 8, and plus 10 is 2. 2 equals 2. Let's check it again, but this time in the first. Y plus x equals 4. 2 plus 2 equals 4. 4 equals 4. That checked. Let's check 3, 1. Y equals x squared minus 6x plus 10. 1 equals 3 squared minus 6 times 3 plus 10. 1 equals 9 minus 18 plus 10. 1 equals 9 minus 18 is negative 9 plus 10 is 1. So that checks. And let's also check it in the y plus x equals 4. 1 plus 3 equals 4. 4 equals 4. Checks. Let's just clean up our table. Okay. And that is it for number 9. Now let's turn the page over and do number 10. Solve the following system of equations graphically. And what we have is x squared plus y squared equals 25. And we have x minus y equals 5. So this first one is now a circle, and the second one is a line. And we know this is a circle because two of the variables are squared. Okay. Now, if you remember, when you have just the x squared plus y squared, okay, that means that the center of the circle is at the origin, 0, 0. Now the radius, we know that r squared is equal to 25, is equal to that second part, because it's x squared plus y squared equals r squared. So we can solve for the radius by taking the square root of both sides. So r is 5. And we also need to just clean up this line a little bit, right? First we got to subtract x from both sides. Then we have negative y equals negative x plus 5. And then we got to divide everything by negative 1 to get that negative y to be a positive y. So y equals x minus 5. So we have our two equations now, we just have to graph them. Let's label our quadrants. 1, 2, 3, 4. And let's show everyone that we're going by ones in every direction. Okay, the center is 0, 0 of my circle. My radius is 5. 1, 2, 3, 4, 5. That means it goes also to the left 5, up 5, down 5. Now I can try and draw a circle in by hand with those 4 points, or I could just take my compass and quickly do it using my compass. And it draws a much nicer circle. And now let me graph my line. My slope is 1, and my y-intercept is negative 5. So I go to negative 5, and I go up 1 over 1, 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 up 1 over, all the way, and then I also go down 1 to the left 1, down 1 to the left 1. And I can see that my line is going to cross this circle twice. So let's put the equation on the line, the original, which is x minus y equals 5. Let's write down our equation on our circle, x squared plus y squared equals 25. Circle our points of intersection, and let's write them down. I'm going to do this one first, which is 0, negative 5, and that's on the y axis, and then it's also 5, 0, and that's on the x axis. Alright, just going to sharpen this. So, all I need to do is my check. So let's do that. First let's check the point 0, negative 5. So x squared plus y squared equals 25. 0 squared plus negative 5 squared, notice they're going in parentheses like usual, equals 25. So we have 0 plus 25. If you didn't put parentheses around that negative 5, that would be a negative 25. So you have to remember to put the parentheses, because when it's in parentheses, negative 5 in parentheses squared is positive 25. Equals 25. 0 plus 25 is 25, so 25 equals 25. It checks. Now let's check it in the original line. X minus y equals 5. 0 minus negative 5 equals 5. 0 plus 5 equals 5. 5 equals 5. Now we check the next point, 5, 0. We have x squared plus y squared equals 25. 5 squared plus 5 squared equals 25. But the y is supposed to be a 0. It's 5 squared plus 0 squared equals 25. So 25 plus 0 equals 25. 25 equals 25. And finally, let's check it in our linear equation. So we have 5 minus 0 equals 5. See, the thing is that when you're plugging in positive numbers, you don't really need to use parentheses. The only time you get in trouble is when you're plugging in negative numbers. So sometimes you'll see me not use parentheses. The only times I don't use parentheses is when, sometimes I always use parentheses, but the only time you'll see me not using parentheses is if the numbers are positive, or if I'm plugging in a number where it's not being squared or multiplied, alright, or subtracted or added to anything. Okay? But otherwise, just to be safe, you should always just plug it in parentheses just to be safe, because then you'll never go wrong. So 5 minus 0 is 5, and 5 equals 5. We're not going to check that on the calculator because it's really a little bit more advanced than this course. And that's something you'll probably do, maybe not even next year, if ever. But it is too advanced for what we have to do. Alright, and that is the end of number 10.